Now let's do a couple examples of boundary conditions. Here's one for the electric field boundary condition. Let's suppose that we know E2 is coming in at 45 degrees. E2 is given by some magnitude, and we can see the angle as shown. The material that it's going from is water, which is distilled water and has no conductivity, up into a region of air. Since there's no conductivity in either of these regions, we know that rho s is equal to 0. So let's apply our boundary conditions. The first thing we have to do is determine the tangential and the normal components, which I've shown you here. The tangential component is the magnitude of E2 times the cosine of theta, where theta is shown here, and E2n is E2 times the sine of theta. That's the normal component. So from this boundary condition right here, we can see that the tangential components in region 1 and region 2 have to be equal. So now we know what E1t is. The next thing that we're going to do is determine the normal components. So the normal component you can see is E2n, which is E2 times the sine of theta. Now how is that related to the region number 1? Well, D1n in this case is going to be equal to D2n because rho s is equal to 0, and D1n is equal to epsilon 1 times E1n, and D2 is epsilon 2 times E2n. So this is epsilon naught, and then we need to look to see what epsilon R2 is. That's right here. That's times 80, and E2n is given right here. So it's the magnitude of E2 times the sine of theta, which is 45 degrees. So now we know what E1n is. E1n is going to be E0 times 80, magnitude of E2 times the sine of 45 degrees, divided by epsilon 1. Epsilon R1 is 1, so epsilon 1 is just epsilon 0. Let's cross those out. So now that I have found E1t, the tangential component, and E1n, I can write the electric field in region number 1. So E1 is going to be E1n in the normal direction plus E1t in the tangential direction. Let's put some directions on here just to help us. Let's say that this is the x direction, and let's say that this is the y direction. So E1t is in the x direction, and that's going to be the E1t I'll put right here. That is going to be the original magnitude of E2 times the cosine of theta, which is 45 degrees. E1n is in the y direction, so it's plus y hat, magnitude of E2 times 80 times the sine of 45 degrees. So there is our electric field in region number 1.